In this video, I want to take a look at exam revision for quadratics. Now, what I want to do here is just recap everything we've covered so far for quadratics, such as completing the square and the discriminant. And we're going to work through a number of exam style questions, so let's get started with the very first question here. Now, we're asked to express this quadratic here in completed square form. So this notation here, or this expression, is completed square form. Now, it did originally say that a, b, and c are integers to be found, but that isn't quite correct. It should be a, b, and c are constants to be found. So where do we begin here? Well, if I inspect this quadratic here, there's a bit of an issue. And the issue relates to the coefficient of x squared. Because the coefficient here is not equal to 1, then it creates a bit of an issue. So what I need to do is factor this coefficient out. So if we write the coefficient here on the outside and factor it out, then I'm going to get x squared. So if this is 10x and we factor 2 out, that becomes 5x. And if this is plus 5 and we factor 2 out, then that becomes 5 over 2. Okay. And you might be wondering why we do this. And the reason we do this is so we can now complete the square on this quadratic here. And all we're going to do at the very end is just multiply through by the 2. So if we begin completing the square here, I'm going to get 2 lots of x plus 5 over 2 all squared. So x plus 5 over 2 all squared. We now subtract this value squared here. So that's minus 25 over 4. And then don't forget the plus 5 over 2. Plus 5 over 2. And what I want to do now is just simplify everything inside the square bracket. Okay, so we keep the 2 on the outside. This x plus 5 over 2 all squared will stay as it is. So x plus 5 over 2 all squared will stay as it is. Minus 25 over 4 plus 5 over 2. Well, the 5 over 2 is the same as 10 over 4. So minus 25 over 4 plus 10 over 4. That would give me minus 15 over 4. Minus 15 over 4 there. Okay. Again, or what I'm going to do now, I should say here, is we want to get rid of that 2 on the outside. Okay, because I want it in this form here. So that's a times x plus b all squared plus c. So we're going to multiply through by 2 here. So that's going to give me 2 lots of x plus 5 over 2 all squared. Okay. And then minus 15 over 4 times 2. So that's the same as minus 30 over 4. And then that's the same as minus 15 over 2. Okay, so minus 15 over 2 there. So that's part A, that's our solution. So A is 2, B is 5 over 2, and C is minus 15 over 2 there. Okay, so that's part A done. For part B now, this is a hence or otherwise, so find the coordinates of the minimum point of the curve. So notice the curve here is the same as part A. So we're going to use our solution to part A to get the solution to part B. It's quite straightforward. We can identify the solution from our completed square form. The x coordinate comes from this bracket here. So if this is x plus 5 over 2 all squared, then our x coordinate will be minus 5 over 2. Okay, so for the minimum point here, then the x coordinate, like we said, that'd be minus 5 over 2. So minus 5 over 2. And for the y coordinate here, that's just the part on the outside here. Okay, so that's minus 15 over 2. Minus 15 over 2. Key thing here is to remember, we change the sign here. So if this is plus 5 over 2, it becomes minus 5 over 2. And if it had been minus 5 over 2, then we'd give it as positive 5 over 2. Okay, so that's our solution to part B. And for part C here, we're given that the curve that we've been working with here, y equals 2x squared plus 10x plus 5, has one line of symmetry. And we want to deduce the equation of the line of symmetry using our answer to part B. So how does our answer to part B help us here? Well, if we think about just quickly sketching our curve here, okay, just quickly sketch it, then we're going to get a U-shaped quadratic because it's a positive quadratic, and we know the minimum point, okay? We know the minimum point here. So if I just extend my x-axis here, so that's my x-axis, and that's my y-axis, okay? Now, you might not have looked at this in a lot of detail, but when we think about a quadratic, there will always be one line of symmetry, okay? And that's about the minimum point. So if we think about drawing this here, it's going to be symmetric or symmetrical about the minimum point in this case. And our minimum point is minus 5 over 2, minus 15 over 2. So minus 5 over 2, let's say that's there. Minus 15 over 2, let's just say it's there, okay? So let's just say, it's not going to look quite right because it cuts through a positive 5, but let's just say my quadratic looks like that. Okay, that's not what it looks like, and that's not quite symmetrical, but let's just say that's what it is. Then it's going to be symmetrical about this line here, okay? Well, that's what it should look like anyway, so it's going to look something like that. That's a bit better. So if I just try and rewrite the last bit, just so it doesn't cause confusion here, and we'll just join it up again. So if I join this up, like so, I think that's a little bit better. Still not perfect, but hopefully that makes sense. Okay, so it's symmetrical about this line. And in that case, all I need then is the equation of this line. And we can get this from our minimum point here. So this is minus 5 over 2. This is minus 5 over 2. And minus 15 over 2. Okay, that's our minimum point there. So in that case, this line here will be x equals. And in that case, it will just simply be x equals minus 5 over 2. So therefore, line of symmetry. The line of symmetry here is given by x equals minus 5 over 2 there. So the key idea here is, remember that the line of symmetry for a quadratic is given by the minimum point here, or the x coordinate of the minimum point. Okay, so there we have it. So that's our solution to question 1. Moving on to the next question then, what I've got here is my function f of x, and I want to find the values of k for which our function f of x has equal roots. Now, as soon as I see this phrase at the end here, equal roots, then we know our question is likely going to involve the discriminant. So let's just recall the discriminant just in case you've forgotten it. So delta here is equal to b squared minus 4ac. Okay, so this is the discriminant. And if the discriminant has equal roots, then this tells us that the discriminant here is equal to 0. Okay, it's one repeated root or equal roots. Okay. So in this case, for our quadratic here, for our function, a is the coefficient of x squared. So that's 1. B is the coefficient of x here. So b is equal to k. And c is equal to the constant at the end. So that's 4. Okay, so our constant here is plus 4. We just need to substitute in everything appropriately here into our discriminant. So b squared, so that's k squared, minus 4ac. So I'll put this in a bracket. So 4 times a, which is 1, times c, which is 4. And this is all equal to 0. So what I want to do now is just solve this here for k. So we get k squared minus, so this is 4 times 1, which is 4, times by 4 again. So we get k squared minus 16 is equal to 0. And from here, it's up to you how you solve this, whether you take the 16 across to the other side and then take the square root, or just factorize from here. Absolutely fine either way. If I just factorize here, because this is the difference of two squares, then I'm going to get k minus 4 and k plus 4. Okay, so this is equal to 0. And from here, we can see our two solutions now for the values of k. So k must be equal to minus 4. And k must be equal to positive 4. Okay. And there we have it. So that gives us the solution to the second question. Moving on to question 3, then what I've got here now is a diagram which shows the graph of the curve with this equation here. So b and c are constants. We're given the point A, so that's 1 minus 6. So that's 1 minus 6. And we also have the point B, which is 2, 0. So this is 2, 0. Now we want to use this given information to find the values of B and C. So they correspond to these values here in my quadratic. So where do we begin here? Well, we have the equation of the quadratic. So y is equal to x squared. So we know the coefficient of x squared is 1 here. A is equal to 1. We've got plus bx plus c. Okay. What I want to do here now is use these two coordinates and substitute those into our equation. And what we should hopefully be able to do here is set up some simultaneous equations. And once we've got those simultaneous equations, nice and straightforward, we're just going to solve them. So in that case, y here is equal to x squared plus bx plus c. So if we know y is equal to this, just substitute our points in. So for point A here, point A, that is 1 minus 6. Well, minus 6 is equal to x squared, so that's 1 squared, plus bx, that's b times 1, so plus b, and then plus c. Okay, simplify this here, then this is 1 plus b plus c is equal to minus 6. In that case, b plus c is equal to minus 7. Okay, getting rid of this plus 1. So that's our first equation. We'll call that equation 1. And then my next equation comes from point B here. We'll substitute in point B in, which is 2, 0. So 2, 0. And in that case, then I'm going to get 0 is equal to 2 squared. That's my x coordinate, 2 squared plus 2b plus c. Okay. What I'm going to get here then is 4 plus 2b plus c is equal to 0. And subtract 4 off both sides. So we get 2b plus c is equal to minus 4. And we're going to call this equation 2 now. Okay. And what I'm going to do now is solve these simultaneous equations. So if we just take it over here, just so I can at least get the equations down to start with. So I've got b plus c is equal to minus 7. I've also got 2b plus c is equal to minus 4. Then we can solve these straight away because we've got plus c here, we've got plus c here, so we can go straight away into solving. Going back to GCSE maths here, I use DAS, so if they're different, the signs are different, you add. If they're the same, you subtract. So because they're both positive c, then we're going to subtract everything. So b minus 2b, so that will give me minus b here. C minus c, that'd be 0. And in that case, then minus 7 minus 4. So just be very careful here. So minus 7 minus 4, that's the same as minus 7 plus 4. Okay, and in that case, we get minus 3. So I've got minus b is equal to minus 3. So in that case, we get that b is equal to positive 3. Okay. And once we've got the value of b here, it's pretty straightforward to work out the value of c. Substitute into either equation 1 here or equation 2. To me, it makes sense to substitute into equation 1. It's a little bit easier to work with. So 3 plus c is equal to minus 7. And in that case, subtract 3 off both sides to get c is equal to minus 10. Okay, so there we have it. So that's the value of b. B is equal to 3 and c is equal to minus 10. So our quadratic here is y equals x squared plus bx, or plus 3x, and then plus c, so c is minus 10, so minus 10 there. Okay, and that's our solution. Moving on to question 4 now, what I've got here is the curve y equals x squared plus bx plus c. And we know this curve has a minimum point at 3 over 2 and minus 5 over 4. And from this minimum point here, we want to deduce the value of the constants b and c. So how do we do this? Well, if we've got the minimum point here, and we know the coefficient of x squared is 1, then we can easily work backwards. Okay, so in this case, what I need to do is write my completed square form. In this case, this will be x minus 3 over 2. Remember, this will be minus 3 over 2 because this is positive 3 over 2 and we take the opposite sign. So x minus 3 over 2 all squared. And then don't forget the minus 5 over 4 here on the outside. Now this is my completed square form. What we want to do now is work backwards. So we're going to expand this and simplify. And we should get the correct expression here for my curve with the values of b and c. So expanding this here, let's just write out the double brackets. So x minus 3 over 2 times x minus 3 over 2. Okay, and don't forget the minus 5 over 4 here on the end. So now all we do is we expand these double brackets and simplify. So I'm going to get x times x, x squared. X times minus 3 over 2, so that's minus 3 over 2x. And again, we get minus 3 over 2 times x. I've got another minus 3 over 2x. Okay. Finally, we've got minus 3 over 2 times minus 3 over 2. So that's going to give me positive 9 over 4. Okay. And then don't forget we've got the minus 5 over 4 here on the very end. So if we clean this up here, well, it's just an x squared. We can't do anything with that, so that just stays as it is. We've got x squared. Now I've got minus 3 over 2x minus 3 over 2x, so this is just the same as minus 1.5x minus 1.5x. In total then, we've got minus 3x. Or you could just use a calculator here as well. That's absolutely fine. A calculator is permitted. And then we've got 9 over 4 minus 5 over 4. So that's going to give me plus 4 over 4. Okay. And remember, 4 over 4 is the same as 1. So what I've actually got here is x squared plus 3x plus 1 there. Okay. And from here, we can easily identify the values or the value of the constants b and c. So b is equal to 3 and c is equal to 1 there. Okay. And that gives us the solution to that question. Moving on to the next question now. A couple of parts to this. So for part A, we want to find the minimum point of the curve y equals x squared minus 4x plus k, giving our answer in terms of k. So let's just begin by completing the square here on this. The coefficient of x squared is 1, so we can just go straight into completing the square. So we get x minus 2 all squared. We subtract this value squared, so minus 4. And then don't forget the plus k. Okay. Now at this point here, we can't actually do anything further with this because this is plus k. We don't know the value of k. So in that case, I can't do anything with the minus 4 and the k here. We just leave our answer as it is. Okay, so that's our answer to part A. Now for part B, we have to find the values of k for which the curve y equals x squared minus 4x plus k has two distinct real roots. And again, as soon as I see this phrase here of two distinct real roots, we know that we need to use a discriminant. So let's just recall the discriminant here. So delta is equal to b squared minus 4ac. Okay. So let's just identify the values of a, b, and c. So a is the coefficient of x squared, which is 1. B is the coefficient of x, that's minus 4. And c is this constant here at the end, which is k. Okay. So it has two distinct real roots. So let's just substitute in appropriately here. So the discriminant is equal to b squared, so minus 4 squared, minus 4 squared, minus, so this is 4 times a, which is 1, so 4 times 1, times it by c, which is k. Now, if this has two distinct real roots, then what we know is the discriminant must be greater than 0. Okay, so if we simplify this here, we get 16 minus, so 4 times 1 is 4, times it by k, we get 4k. So 16 minus 4k is greater than 0. And what I want to do now is just solve this linear inequality. So 16 is greater than 4k, which in other words would be the same as saying 4k must be less than 16. Okay, so if 16 is greater than 4k, then the opposite is true. 4k is less than 16. Okay, and from here we just divide by the coefficient of k. So in that case, we get that k is less than 16 over 4, which is 4. Okay, so as long as k is less than 4, then it satisfies this condition that it has two distinct real roots, and that gives us the solution to that question. I'm moving on to the last question here. This is a bit of a tricky one. This isn't something that you can really be examined on, but I think it's very good practice for understanding how to solve quadratics by completing the square. What we're actually looking to do here is prove the quadratic formula. So hopefully you do recognize this here as the quadratic formula. So this is something that you should be familiar with from GCSE maths. And what we're going to do now is prove this result, starting with this quadratic here, by completing the square. So do take a moment here to think about this, pause the video, have a go. But if you're not too sure where to begin, let's have a look at this together. Now the first issue here is that my quadratic here, the coefficient of x squared is not 1, okay, it's a. So we need to get rid of this a here, and what I'm going to do to start with is just divide through by a. Okay, so in that case we get x squared plus b over a x, so b over a x, and then plus c over a. Okay, and this is all equal to 0. Now from here, because the coefficient of x squared is 1, we can actually begin completing the square. So don't worry about the fact that we have algebraic coefficients like this. It works in the same way as what we would do when we have numeric constants. So we're going to get x here plus half of this coefficient. So if this is b over a, if I divide that by 2, we get b over 2a. Okay, dividing by 2 is the same as timing by a half. We get plus b over 2a, and this is all squared. And now subtract this value squared. So if we square this, that would be b squared over 4a squared. But we subtract that, so that's minus b squared over 4a squared. And then don't forget we've got this plus c over a. So plus c over a. And this is all equal to 0. Okay, that's what we began with here. So where do we go to next? Well, what I'm actually looking to show here is my solutions to this equation, this quadratic equation here, is equal to this. So what I want to do is just rearrange for x. So we need to get rid of this, or this part here, this minus b squared over 4a squared plus c over a. So what I'm going to do is just take that to the other side. So I'm going to get x plus b over 2a all squared. And this is going to be equal now to b squared over 4a squared. So that becomes positive, like so. And this part here becomes negative, so that's minus c over a. Okay. Now, what I'm going to do here is get this over a common denominator to start with on the right-hand side. So I'm going to get x plus b over 2a all squared. And that's going to be equal to b squared. So if I get this over a common denominator, so that's 4a squared, that's a. So I need to times this fraction here by 4a. Okay, if I times it by 4a, we get two common denominators here, or a common denominator of 4a squared. That's going to be b squared minus 4ac, because we need to times the numerator by 4a as well. So that's 4ac, and this will all be over 4a squared. Okay. Now, if I just take a moment just to look at what we've got here on this line, and we take a look at our required result here, then we can see it's starting to take shape already. Okay, notice the b squared minus 4ac here, we've got that here. Okay, so it's starting to look pretty good. Obviously, we need to do a bit more work, but we're getting there. Now, remember, we're rearranging for x here, making x a subject, so I need to get rid of this square. So to do that, we're going to square root both sides. So let's go back to the top here. So if I square root both sides, I get x plus b over 2a on my left-hand side. And on the right-hand side here, so just be very careful here. If I take the square root of this expression here, that's the same as taking the square root of the numerator over the square root of the denominator here. Okay, so the square root of the numerator, well, that would be the square root of b squared minus 4ac. So that's my numerator. In fact, let me just get rid of that just to finish with here, because we need to make a bit more room. So let's try again. So this is the same as the square root of b squared minus 4ac. Okay, so that's the square root of the numerator over the square root of the denominator. Now the square root of the denominator here, if I square root 4a squared, that would just give me 2a. Okay, so we get this denominator of 2a. We're just going to be very, very careful here. When I take the square root of this expression here, we can also include the negative solution. So it's going to be plus or minus. Okay, so plus or minus. And we're pretty much there now. If you look at this here, I've got the plus or minus the square root of b squared minus 4ac over 2a. And we can see that everything here from the right of my cursor here is what we've got on the right-hand side here. The only thing we need to do then is get rid of this plus b over 2a. And when I subtract that onto the other side, what I'm going to get then in this case is x equals, so that's minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, because these are already over a common denominator, then we can write that as a single fraction in this case. So x is equal, so that's going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, which is exactly as we wanted to show here. So as required, and that gives us our proof there of the quadratic formula, okay, by completing the square. And there we have it, so that's our solution to that question, and that brings us to the end of this video. In the next video, we're going to take a look at quadratic simultaneous equations.